coding for a random motion. And also we will just first of all create a boundary condition so that the particle cannot go beyond particular limit in x, y, and z direction. X, y, and z direction won't go beyond this limit, these limits. Okay, in order to actually give a random motion to a particle, it has three directions or 3 degrees of freedom, and in each degree of freedom it will be free to move, and we will be quantifying it as +1, -1, or 0. Plus if it moves in the positive direction, negative, -1 negative direction, and 0 like same state. And the same thing will happen to each of the axes x, y, and z axis. This will be logic for the random motion, and the random numbers generated will be given by some MATLAB function, or we can actually generate the custom function ourselves to generate these random numbers -1, 0, or 1 to move direction, move in different direction. And the thing is like the unit displacement taken would be only 1 or 0. Okay, and when it will reach beyond a particular limit, it won't be allowed to go beyond that limit. So in next live session we'll be creating a 3D space, and these spaces, they will be limited, there will limit placed on that from 0 to 20 in x direction, 0 to 20 in y direction, and 0 to 20 in z direction. And a particle will be put on the middle of like 10, 10, 10 position vector x, and z, and it will be coded to move in this space. And this time won't have any effect on iteration, because we won't be talking about time. We will be rather talking about the number of iteration steps, number of iterative steps that will become a count. And for every loop, for 1 to 100, we'll go for 100 loops and see how the particle will move in this space. This will be the problem we will be. Okay, hello there. Today we'll be just coding for the random motion of the particle on the single particle we considered, and I have already explained in the video that what exactly we will be doing. So let's get it started. This was the code that we just made yesterday, accelerated motion. So we're gonna make same thing here again, copy paste it. Okay, save it as random motion as explained earlier in the video. Yeah, I will be first of all bounding these axes. Yeah, we usually use this initialize function to actually develop a three-dimensional space, and we use this set of function as bounds outside the function. This time these bounds would have literally meaning to it, because we won't let the particle go outside these bounds. So first of all, in this one we don't need time for this coding, this part random motion, and as 1 x 0, I think it's good. We can create bound of x as 0 to 20 distance in x-axis. Bound in y would be same 0 to 20, and bound in z would be 0 to 20. So we will give these bounds in this function. Will from now onwards we'll be giving bounds to the initialize function. Okay, this is it, and we don't need this time. We can create bound of x is here, bound of y is here, and bound of z is here. And we will use this function to initialize our initialize function. Okay, yes, set everything is good, and here bound of x, bound of y, and comma bound of z will be here. But this time it's now meaning like if we just bound the plot, whatever we're gonna bound the particles, we will do it in state function. not here actually. Okay, acceleration, we don't need acceleration for now on because it's random motion, so we will call this as initialize. That's given, and this would be called as initialize, and it will keep this frame here. For these frames is get frames needed for the video thing. If you don't want to export the video, and here would be code part. Yep, code part will be here. No, yet what we need. Okay, let's. So what was the problem was like random motions. Okay, before going on with this coding, we need to generate random numbers, -1, 0 or 1. And how will we do that? Let's find out. Help. I think there's a random function rnd. Let's see there, rand and range, rand rnd documentation. Let's see how can we generate 3 random numbers only, -1, 0, 1 or 1 2 3, whatever they will give. Let's see how can we proceed to the problem. Okay, rand 10 to create a 10 by 1 column vectors of uniformly distributed. This is uniform distributed in your number of random variables. They will be uniformly distributed, like normally distributed in the mean, around the mean. The frequency will be more. It's what, -5. It created 10 by 1 in the interval. This is good. I think this will work. -5 to 5, like this, and this will distribute between 0 and 1. 0 and 1. Okay, wait a second. This will also work. Yep, let's see random. Let's do like this. Okay, create a function here. Rand. I need one number. Yep, run it. 0.817. 0.817. So he's gonna say from minus. Okay, he's gonna get 10 by giving this 5 plus 5. Okay, it's been. I need to plus this number 1, 2, 1, 2, 3. Okay, I can go for like 1, 2, 3. Then if I random from the distributed between 10 to 5, this is also good. Let's see this one. Rand I integer. 1 comma 1 only. 1. I did not. There's 1 2 3. Let's see how it will go. Okay, it generated 3. Yep, I need this thing. Again 1 2. Yep. Now we can do like this. We can create a matrix. Let's see. Wait a second. -1 to 1. 0 1 1 -1. Okay, this will work. This function is good. This function will be used to generate a number between y -1 0 and 1. From these 3 numbers we can randomly choose one number. Can we do like this? Don't mention this if it can be done. Okay, this can also work. Don't have to try to mention it. Okay, this function will be used. Okay, done. So I have to first of all use it in state functions. For count, I told you we'll go for 100 counts, less than equivalent to 100. Okay, 1. XTF, okay, we don't need. Okay, we just need to. No, we don't need this thing. We'll keep it here. Nice. Today code is looking a little bit nicer. XYZ TU, I don't need. Okay, I just created a state. My goodness, but I don't need this state. Okay, I'm gonna create a new function. Call it random rnd, random state. I don't need u, I don't need ti, I don't need a, I don't need dt, h I don't need. For now, tf I don't need, u I don't need. I just need the state. Okay, this one I can go later on. Just keep it 0 for now on. just tf, I don't need this, I don't need this. Okay, this has been created. You can create like copy it here, paste it here, xyzh. Okay, for now this is good. Save it, save this function. Okay, now what I told, random moments, I have to give a random moment to it. So random moment, I can go like this. I will add whatever is x is equal to x plus and a random moment, y is equal to y plus random moment, and z plus random moment. Okay, this will work. But I told you we won't go beyond bounds. So the thing is, we can actually delete this thing. So I have to give 3 more things to here: bx, by, bz. Okay, dokie. My goodness, it should not go beyond bounds. First of all, we will go for x. If x is greater than bx, it was second, bx2, wait a second, wait a second, bx2, can you, oh, not bs, wait, error, it show me the error, bx2, okay, if bx2 I want it to just go for again random x is going to while, okay, while is good, while x is greater than bx2 or this, or x is less than bx1, why have I wrote x is greater than bx2, and I think this will work. There may be another guy who might do better than this. This is just my way, I think. Okay, why z z z z. I'm giving bx here, bx comma by comma bz, by here, by here, bz here. I think this should work. Is there anything else? Okay, unless and until it's not falling, while this is this, it should not be actually x is greater than x2 or less than. Go for random motion until it is giving you bad motion. Let's see if it will work. Let's hope so. Oh yeah, it's working. Let's see. Okay, we can keep the particle at, I told you, 10, 10, and 10. Yeah, this is the random motion. We have generated the random motion. Okay, this is it. I think this is will be it for this session. Yeah, it's good. Okay, in the next session we will develop lots of these particles, like this one. We'll develop lots of particles, and unless and until they like collide with each other, the loop will end. We won't go for count is equal to 100. We'll like when two particles collide, the loop should end. Okay, good. It's working very good. Okay, this will be it for next. It will be like random motion for number of particles, unless and until they are colliding, they will stop. Okay, for this set, 3 functions have been developed. We don't need the next this one. Keep these 2 here. Random motion here. Control C. Name it R&D motion collide. Next, we'll be doing this thing. There will be no introduction about this next coding, no introduction video, just straight on we can go coding later on. Okay, thank you, that was it for